Now let's focus on continuous probability distribution. So this one applies when your outcomes are uncountable. In other words, they can take any value. Okay, they take any value in a range. So for example, height of people, weight of boxes, temperature, time to finish a task. So for example, your temperature, it could be 34, 32.3, minus 5.2. It can take any range of values. Now, to calculate your PDF for your continuous variable, what we do, we calculate probability over an interval. This is important to understand that you calculate probability over an interval. And the area under the curve that represents, that tells you the probability for that particular interval. Also, unlike your discrete case, the probability for a single value here is zero. So let's try to understand this through a visual diagram right here. So let's say this is my probability distribution function right here. This is my curve, okay? My fx is given to you. And you have to calculate the probability of x between x1 and x2. You have to calculate what is the probability that your value x, okay, it falls between x1 and x2. Well, if you remember from your calculus class, the probability would be equal to the integral right here. Okay, this is the integral, and this integral is nothing but this area. That's all it is. So if you can calculate the area directly by just by looking at the picture, if you can find the area, that's great. Or you can actually use your integration tool right there. Now, two key points. Number one, let's say this is a point A. Okay, let's say this is your point A. You have to find the probability at x equal to A. In that case, this is going to be zero because the area, okay, the area over here is zero. This one is all is not a finite, not a finite value. The area is not finite. It is zero. Likewise, if you calculate the total area, okay, let's say you take all the area, you calculate them all values, the answer would be equal to 1. That's what this expression is saying, that the total area is equal to 1. So there are two types of continuous probability distribution function that we're going to be focusing today. One of them is uniform distribution. The other one is normal distribution. In uniform distribution, this is how your shape of your curve looks like, almost like a rectangle. Okay, you can see it's almost like a rectangle right here. So this is my random variable x, and let's say my x equal to a over here and my x equal to b over here. And you have to find this right here. This is your probability of something happening when that x value is between a and b. So that's what that is. Well, this is easy. Well, if you think about it, my area equal to 1, right? This is my area, and my area equal to 1. And the formula for my area is this distance, right? This, which is b minus a. So b minus a multiply, okay, b minus a multiply by this number right here, okay, whatever this number is, but multiply by this number, and this number is going to be equal to 1 over b minus a. That's the only way it's going to be equal to 1, right? So for this to satisfy, this has to be 1 over b minus a, and this is how you get this 1 over b minus a over here. So this height is 1 over b minus a, and this is how you come with this expression right here. So this one says that fx equal to 1 over b minus a as long as your x is between a and b. So this height, okay, this height is 1 over b minus a all the way over here. As long as your x is between a and b, after that, as long as your x is not between a and b, it becomes 0. Then you have normal distribution curve right here. Normal distribution curve, another name for that is Gaussian. And in this case, you can actually find the area very easily. You can look, you don't have to do, this is the function by the way, but you don't have to integrate this function. You can find the area using this using this z table. So there are z tables available, and using z table you can find the area underneath the curve. Imagine that a bus runs every 10 minutes. This is the bus that runs every 10 minutes, and that you arrive randomly at a bus stop. So you can be arriving at the bus at any given time. So your waiting time X, let's say it follows a uniform 0 to 10 distribution. Okay, what it means is that you could be waiting for the bus anywhere between 0 to 10 minutes with equal probability. So after you arrive at a bus stop, what is the probability that you could be waiting less than 4 minutes, or you could be waiting more than 7 minutes, or you could be waiting between 3 and 8 minutes, between 3 and 12, between 11 and 12, and exactly 2 minutes for the bus? Okay, to do this question, the first thing you want to do is draw your step graph. So this is my step graph. So you draw your x. This is my waiting time right here. This is my x is my waiting time, and your waiting time can be anywhere between 0 to 10. Okay, now you know your total area, right? The total area equal to 1. based on what you know your total area is 1 and you know this is equal to 10. By the way, your waiting time could be 0.1, could be 1.2, could be any one of these values. Doesn't have to be integer value, it can be decimal values too. So it could be 6.1, 5.1, any one of these values. So I know my total area is 1 and I know this is equal to 10. So what is my height in this case? Well, using a simple geometry, your height is 0.1 because 10 multiplied by 0.1, the answer is 1. That's your area. Okay, so once I know my height, this way I can determine my function. So this is how I come with this function. This function says that my fx equal to 0.1. My fx equal to right here, this value is going to be 0.1 right here, as long as my x is between 0 to 10. So as long as my x is in this area, my fx is going to be 0.1. After that, my fx becomes 0. So on this side, my fx equal to 0, and on this side, my fx equal to 0. Okay, so let's start with the first question. What is the probability that you wait less than 4 minutes? In other words, what is the probability that your waiting time is between 0 and 4 minutes? The answer would be the area between 0 and 4. So this is my 0 and this is my 4 right here. And the area between 0 and 4 would be this region right here. And this would be the height, which is 0.1, right? This is my height right here, 0.1 multiply by the length of your base right here. This is 4. So 0.1 times 4 is 0.4. So the answer is 40%. Now, what is the probability that you could be waiting more than 7 minutes? In other words, what is the probability that your waiting time x is between 7 and 10 minutes? Remember, you can never wait more than 10 minutes because you know that the bus arrives every 10 minutes. So, the probability that your x is between 7 and 10 would be the area between 7 and 10. So this is my 7 right here and this is my 10. So the area in this case would be this area. And the area is going to be your height, which is 0.1 multiplied by the length of this base right here. This is 3. Okay, so 0.1 times 3 is 30% chance. Okay, what is the probability that your waiting time is between 3 and 8 minutes? So in this case, I have to calculate the probability that my waiting time is between 3 and 8 minutes. That would be the area between 3 and 8. My 3 is over here, my 8 is over here. So calculate this area right here. This is my area. The answer is this area right here. And again, my height in this case is 0.1 and this length from here to here is 5. Okay, this is 5. So 0.1 times 5 is 50. Is 50% chance. There's a 50% chance that you could be waiting between 3 and 8. What about, what is the probability that you could be waiting between 3 and 12? So this is my 3 right there, and my 12 is somewhere over here, 12. Okay, but in this case, the answer would be this area from here. Okay, go all the way up to here. But remember, this thing right here, okay, this thing, your curve actually drops. So there is no area in this side. So in this case, the probability that you wait between 3 and 12 is equal to the area between 3 and 12. And the area between 3 and 12 right here, this would be equal to this area, right? Just this part of the area because there is no area over here. So in this case, it's going to be 0.1 times 7 because this distance from here to here is 7. So 0.1 times 7 is 70. So it's going to be 70% chance. What is the probability that you could be waiting between 11 and 12 minutes? So now 11 and 12 minutes, but my 11 is over here, right? And my 12 is over here. So 11 and 12, well, if you think about it, look over here. There is no area. There is distance from here to here is 1, but there is no height, okay? So the area is essentially 0. So the probability that you could wait between, your waiting time is between 11 and 12 is the area between 11 and 12. And this would be your height, okay? Your height of your fx is 0. And this base right here is 1. So the answer is 0 right here. So the answer is 0% chance, which makes sense because you know the bus arrives every 10 minutes. Okay, what is the probability that you wait exactly 2 minutes? Okay, so exactly 2 minutes is right here. So exactly 2 minutes is over here. So you draw a line like this. Now exactly 2 minutes means that your area between 2 and 2. Well, the area between 2 and 2 is 0, right? Because this has a height is 0.1, but it has no width. And because of that, the answer is 0. So let's say that the adult male heights denoted by random variable x in a city is normally distributed. Let's say the data is normally distributed for the heights. And the mean value for the height is 170 centimeter and the standard deviation for the height is 10 centimeter. So if you go to city and randomly pick an adult, then what is the probability that his height, what is the probability of this guy height? This is a random guy you just picked up. His height is less than 155 centimeter. His height is greater than 190. His height is between 160 and 180 centimeter, and his height is exactly 190 centimeter. All right. now you know that your height is normally distributed. Okay, so anytime when you see a data that's normally distributed, what you do, you convert your data, you convert your values, convert your data into a z-score, and then we calculate their probability using z-table. The reason we convert it to z-score, because we know how to calculate your probability using z-table. That's a lot easier. Okay, so let's do question number A first. So what is the probability that his height is less than 155 centimeters? So let's convert our x equal to 155 into a z-score. The way you convert your x into z-score, you say you use this formula: x minus mu divided by sigma. That's the formula you use. So in this case, I know my x, right? So this is the formula I'm using. I know my x is 155, right? I know my mu is 170, right? That's given to you. And I also know my sigma. Sigma, in this case, standard deviation is given to me 10. Just substitute the values. I substitute my value 155 minus 170 divided by 10, and the answer comes out to be minus 1.5. So now the question becomes probability of x less than 155, okay, is same as probability of z less than minus 1.5. So whatever this value is, this is my mu right here. My mu was 170, and then my x in this case was 155. So this is my 155. So what just happened, that it got mapped. Okay, 155 came over here, it got mapped to this value, which is minus 1.5. And my mu right here, which is 170, this gets mapped to 0 right here. So my mu, it gets mapped to 0. So you have to calculate the probability that x is less than 155. In other words, you have to calculate this area, right? This area is same as calculating this area right here. And we can calculate this area a lot easy because we have z-table at our disposal. So using z-table, we can calculate this area. Okay, so to calculate the probability that your z is less than minus 1.5, we actually look through the z-table. So this is my z-table right here, assuming that you know how to go through the z-table. So minus 1.5, it's in this area right here. This is my minus 1.5. The answer is 0.0668 right here. So coming back to this, so my answer is 0.0668. In other words, it's 6.68% chance that the probability that you randomly pick a guy, his height is less than 155 centimeter. Now, what is the probability that his height is going to be 190 centimeter, more than 190 centimeter? So do the same thing, convert your x equal to 190 into your z-score. I'm using the same formula right here. Substitute your value of x. In this case, my x is 190 and my mu is 170, same value. Substitute your sigma, 10. Okay, and the answer comes out to be 2. So the probability that your x is greater than 190 is same as probability of z greater than 2 value. Okay, greater than 2. Again, this is the area under the curve, and you can use your z-table. So using your z-table, your answer would come out to be 0.023. So the answer is 2.3%. I'm assuming you know how to use z-table, okay? All right, so the answer is 2.3%. There's 2.3% chance that his height is going to be more than 190 centimeters. So this guy height is, the probability that his height is more than 190 is 2.3% chance. Okay, what is the probability that his height is going to be between 160 and 180 centimeters? So let's convert our x equal to 160 into the z-score. Use the same formula right here. I'm using the same formula, putting my 160 in there, putting my mean, putting my sigma, and the answer comes out to be minus 1.1, minus 1.0. So my x equal to 160 has been mapped to minus 1.0. Likewise, x equal to 180, okay? Calculate your z-score and it's mapped to plus 1.0. So in this case, let's say my 160 is over here. All right, this is my 160 and this is my, let's say, my 180 right here, 180. So this one is mapped to this value right here, and my 180 is mapped over here right here. Okay, so let's say this is my minus 1, this is my plus 1. So to calculate the area, I mean to calculate the height, and the probability that your height is going to be between this range, okay, in this that the probability of person height is going to be between 160 and 180 is this area right here, and this area is the same as this area right here, and you can calculate this area using z-table. So come to the z-table. So the probability that your x is between 160 and 180 is the same as probability that your z is between minus 1 to plus 1. Okay, minus 1 to plus 1 in this range, and this is the area under the curve. And assuming you know the z-table, my answer comes out to be 0.6827. So 68.27% chance that his height is going to be between 160 and 180 centimeter. Now, what is the probability that his height is exactly 190 centimeter? Well, exactly 190 centimeter in this case, Let's say my 190 would be somewhere over here. Let's say it's 190 is over here. So map this down. And well, if you think about it, you don't really have to map, because if you think about it, the height is basically it's a finite height, but it has no width. So the area is zero. So in this case, we don't need to convert this into z-score, because we know that the probability for x equal to exactly 190 is zero.